Welcome to our talk on our favorite functions. My name is Louise Haddon, and I am going to be introducing us to you, as well as introducing you to our exciting topic, our favorite SAS functions. As you can see, Rich Ann Watson and Dee Dee Schreiber-Gregory come from different organizations, have different job titles, and different concentrations, but we are united in our admiration for SAS functions, and we are all scientists. We are going to cover three exciting groups of functions today. Those perfectly fabulous feline CATT functions, which I will cover, PRXMATCH and PRXCHANGE, which Rich Ann will cover, the perfect functions for pattern matching, and those stalwart mainstay functions we all know and love, dealing with mathematics and statistics, which Dee Dee will cover. We hope not only to demonstrate our affinity for these chosen topics, but to inspire you to make our favorite functions your favorite functions. Functions act as subroutines that take arguments, perform operations, and return values. They can be used in the data step, in where statements, in macros, in selected procedures, and in SQL. They cover a variety of different topic areas, such as character or string manipulations, fuzzy matchings, mathematical calculations, and statistical functions, and have been famously explored in many papers and books. We will explore SAS function syntax briefly before taking brief looks at our very favorite functions. We can't really discuss specific sets of functions without first understanding how functions work. Functions require either an argument, which can be a variable name, constant, or any SAS expression, including another function with multiple arguments that are separated by commas, or they can use any form of a SAS variable list, including individual variable names. If more than one variable list appears, separate them with a space or with a comma or another of. Or they can use a currently defined array. Additionally, some functions take modifiers, enhancing their flexibility and power, as we will see in our examples. First up in the favorites list is my favorite functions, the CATT functions. Version 9 introduced four new functions, CATT, CATS, CATT, and CATX, and three new call routines, call CATS, call CATT, and call CATX, that replace the clunky vertical bar syntax that we see at the bottom of the screen here, and add some enhanced capability to character string concatenation. In version 9.2, the CATQ function was added. CAT calls and CAT functions are based on other SAS functions. Trim and trimn remove trailing banks for a character field. Left justifies a character field. Strip, a newer function that combines trim left functions, all go into the CAT functionality. Let's see how we can improve on the old concatenators in the next slides. The CAT function is identical to simply using the concatenation operator, the double bars, to string literals, variables, and expressions together. No leading or trailing banks are removed from arguments. As with many character functions, the default result for CAT functions has a length of character 200. Always set your variable lengths in accordance with what you want. For the CATX and CATQ functions, make sure to leave enough room for delimiters and quotation marks. The CATS function removes both leading and trailing blanks before concatenating character arguments. It is the equivalent of using the strip function and the concatenation operator. The end result will not contain any blanks. A good mnemonic device is that S is equivalent to strip. The character arguments are stripped of any blanks before being joined. The syntax is the same for the CAT function, replacing CAT with CATS, but the result will be different. The CATT function removes only trailing blanks before concatenating character arguments. The end result will contain blanks if any arguments have leading blanks. A good mnemonic for this function is T is equivalent to trailing or truncate. Trailing blanks are removed from character arguments before they are joined. Again, the syntax is identical to the CAT function, replacing CAT with CAT, but leading blanks will remain in the result. We will see an example of using CAT in our real-life examples coming up. The CATX function performs just like the CATS function, but it adds the extra capability of inserting a delimiter between arguments. This is handy if you want a delimiter between arguments but don't want any extra spaces. A good mnemonic here is X is for extra. The CATX function adds something extra between arguments and cleans up after itself by automatically ignoring missing arguments, thus ridding the result of unwanted extra delimiters. The CATQ function is the newest member of the fabulous feline function litter as of SAS version 9.2. It is similar to the CATX function with the added option of quotation marks around arguments in the end result, as well as other operations. A mnemonic here is Q is for quotation marks. Remember to add some extra length for the quotation marks and any other items that you add to your string. CATQ begins with a modifier, which contains information about how you want to output the field. CATQ is capable of creating character variables from numerics, as well as removing leading and trailing blanks, adding single and double quotation marks, hexadecimal literals, word literals, etc. The modifier in CATQ offers the ability to direct its behavior in a variety of ways. There's not enough time in this presentation to discuss all the possibilities. Please consult the SAS documentation for more details. This function can be very handy for creating variables with delimiters that will be put out to a flat file. Uses example 1 tells us how to search for characters in numeric variables and find specific diagnosis codes. As you can see in the code, the input is 3 diagnosis variables, and these happen to be character diagnosis variables. And we can loop through an array of diagnosis variables, and it will tag specific diagnoses. And this can be very handy where we're just trying to look for a patient that has a specific diagnosis or a group of specific diagnoses. And this will just give us a dummy whenever it encounters that. And it's very quick, and we don't have to do a lot of array processing. Uses example 2 is similar to uses example 1. We search for diagnoses in different DX fields by using the find and the CATX functions. The input includes a variety of diagnoses codes and also creates flags for specific diagnoses by concatenating all DX codes with the delimiter using CATX, then using the find function to search for the delimiter and specific code. And the reason that we search for the star 250 is that 25 or 493 could occur anywhere in a diagnosis, but we want to find diagnoses that start with 250. And by using the star that we have added using the CATX, that allows us to pull that specific diagnoses. Usage example 3 is from a program which generates 15,000 data-driven provider reports automatically in SAS every month. The specific use of CAT functions here is to create a paragraph to print in a report using a length statement and the CAT function. The input is a data step which creates a very long text string. You can see at the top the length statement is 32,000 rather, and The strings are strung together by using CAT-T. And if you notice in footer 2, there is a space at the beginning of that sentence. And when you concatenate it, that allows you to create essentially a paragraph. We use PROC report with the no header option to generate the paragraph. As you can see, it resulted in a path that printed out at the top of shown a couple slides ago. Now I am going to turn it over to Rich-Ann to discuss some exciting PRX functions.
Thank you, Louise. So my favorite functions are the PRX functions. These are Perl regular expression tools that are available in SAS and other programming languages that utilize flexible pattern matching. While these functions can be useful and used in place of some of the commonly known SAS functions, they can be more powerful because of the robust search capabilities. There can be a bit of a learning curve when using the PRX functions for the first time because of the use of various meta characters that are used to build the search patterns. There are several functions in the PRX family of functions. However, we will only focus on the PRXMATCH and PRXCHANGE. PRXMATCH functions uses either a regular expression ID or a Perl regular expression and can be used to search for a string or strings within another string. PRXMATCH can be used in place of index or find functions. With Perl regular expression, you can look for a string at the beginning or end of another string, or you can ignore casing, and you can search for multiple strings within a string. If you're using a regular expression ID, you need to use PRXParse. And in the examples, we will illustrate the use of PRXParse. However, the expression in PRXMatch or PRXChange can be used in place of the PRXParse and assigned to an ID value. That ID value can then be used in place of the regular expression within PRXMatch or PRXChange. So before we get started on these functions, I want to show you some data that we're going to be working with. So we're given this following data set, and we want to subset the data for terms that contain arrhythmia, pruritus, or dermatitis. This is an adverse event data set. And as you can see, there are a variety of ways the term can come in. So how do we subset the data without knowing all of the terms? So within clinical industry, we get data throughout the course of the study, and at the beginning of the study, we don't know all the possible terms, and so we need to be able to programmatically do the subsetting without knowing what the data is ahead of time. So we could use standard subsetting techniques such as the find functions. We can apply the find function to each individual term as shown. Another technique would be use the question mark operator on the where statement. Both of these yield the same data set, but that is not what we want to discuss today. I want to illustrate a different approach. Now, I want to point out that these are, very simple statements. However, sometimes these complex strings search patterns can be a little bit more complex, which is where we want to introduce the PRX functions. So we're going to use PRX to actually subset the data. PRX is one of my favorite functions because of its powerful search capabilities. Yes, the syntax is a bit daunting, but once you get used to the syntax and understand what the various meta characters represent, it can be a great function to add to your programming toolkit. So let's delve into the syntax a bit. With PRXMatch, you have the ability to search for multiple strings within the source. We want to search the AE term for pruritus, arrhythmia, or dermatitis, and so we're going to build our search string. The vertical bar indicates alternation, so it's looking for either pruritus or arrhythmia or dermatitis. The I indicates we want to ignore the casing, so we don't care what casing it is, whether it's all uppercase, lowercase, proper case, it's going to ignore casing. From the start of the forward slash to the second forward slash before the I is the search expression. So we'll have this forward slash with our various search strings. If we have multiple search strings, then we're going to use that vertical bar to indicate the or, and then we're going to close that slash, and then we add the I in there for that, ignoring the casing. The code yields the subset of AEs. This is the same same subset of data that would be produced if we use the find function or the question mark operator on the where statement. Now notice that without that I meta character specified, the subset would not contain any records since all the data is in uppercase and our search string was in lowercase. And so using this PRXMATCH function allows us to have this more robust search capability without ever seeing the data. We just know that we want to look for key terms. Using our subsetted data set, let's take a look at PRXChange. We want to categorize the terms relationship to study drug as related or none. We could use a standard technique such as if then else or select statements, but how about we try this using PRXChange? Getting used to the syntax, we use the meta character S to indicate that we want to do a substitution. And so within the PRX functions, there are several meta characters that control how the search patterns are going to work. And so I highly recommend that you read through the documentation to understand how all these meta characters work. We'll just touch briefly on some of the meta characters in this presentation. So S is one of the meta characters, and it indicates that we're going to do a substitution. Notice that the placement of the S is prior to the first forward slash. The forward slashes indicate the start and end of the pattern. And so you'll see in this particular function, there's there's 3 forward slashes. So the first forward slash and the second forward slash, anything between that is the pattern that we're going to be searching for. That third forward, so as I mentioned, that first 2 is going to encase the pattern. After the second forward slash begins the value that should be substituted when the pattern is found. And so you'll see that we're going to be looking for specific pattern within the term AEREL, and then we're going to replace, if we find the pattern, we're going to replace that entire portion of that string with the word related. The substitution is value ended with that third forward slash. And the next argument is going to indicate how many times we want the substitution to be made. So in this particular example, we know that the value can only be substituted once. However, if you use a -1, it's going to say, indicate that you want to repeat until the end of the source value. As I mentioned, because of this particular variable can only contain the one possible value, it's only going to be replacing it one time. However, if you have a long string of text or a paragraph, such as in Louise's example where she was creating that paragraph and say she wanted to redact some information, she could use the PRX function to search for particular information throughout the entire search string and redact it using the PRXChange. The -1 indicates that you're going to search the entire search string and make replacements throughout the entire string. The grouping of meta characters contains a question mark as the first element inside the parentheses. The characters after the question mark indicates the type of modifiers. In this case, we want the pattern to be case insensitive. So we use the I modifier. This technique could also be used in PRXChange instead of using I at the end of the search pattern. So if you recall on the PRX match that we had previously, we had the I at the end of the search pattern. We could use this technique as well within PRX match to ignore casing. The parentheses indicate that we want to group the characters and store in a capture buffer. The backwards slash with W indicates that we want to match on a word character, and the plus sign indicates that we want to match on multiple word characters. Without the plus sign, then it would match only on one word character. So based on this search string, we are looking for anything that starts with POSS with some additional characters, PROB with some additional characters, DEF with some additional characters, or REMO with additional characters. Now, it may have additional characters, it may not, but it's saying we want at least those characters, and then we may have some additional things added on. With PRXChange, we were able to create the relgr1 variable. PRXChange can be very beneficial when you need to mask data such as names, addresses, social security number, and phone numbers. And this is what our data ends up looking like. You'll see that we have our rel term, and now we have our grouping, and we didn't have to use a bunch of if-then-else statements to get this grouping variable. And at this time, I will pass it over to Dee Dee.
So by this point in the presentation, hopefully we've introduced you to at least a couple of functions that maybe you haven't used before, that might be new to you, or that maybe you have used, but you didn't realize that it had that many uses. So hopefully we were able to expand what you were able to use in your toolbox to this point. Now, obviously, my part of the presentation is about mathematical and statistical functions. These functions we pretty much are all aware of, regardless if we are new to SAS or if we've been using SAS for a long time. The reason that these are my favorite functions is because it's very easy to misuse them. So it's very nice to be able to have a large quantity of different functions that we can rely on depending on the statistical procedure specifically that we're trying to use. So mathematical and statistical functions themselves, of course, are some of the most common and frequently used formulas that you will see available within SAS. These formulas are created to make code cleaner and to reduce the chance of error. So less, I put the parenthesis in the wrong spot or a semicolon in the wrong spot. They clean up a lot for you. Depending on the function, there are different paths that are used to employ that particular math or stat function. These can be completed through the data step, PROC SQL, or within SAS IML. Generally speaking, function availability exists within the path that it would be commonly found or commonly used. For example, in the data step, we're doing a lot of variable creation. So any functions that kind of assist with that, you're going to find in the data step. For PROC SQL, you're going to see a lot of functions that are going to assist with the construction or summary of some of the data that we have. And then in SAS IML, if you have some handcrafted procedures that you're working with, you're going to see some more functions in that realm as well. That's not mutually exclusive across. You're going to see some cross functions across all of them. And maybe some that are specifically geared towards one that aren't available in another, but that you could theoretically see in another. But that their existence generally makes sense. So normally when you need a function, it's probably available. These functions are most useful in the data preparation phase and can be seen when you are exploring or summarizing data, trying to locate errors within your data set, creating variable and metrics that represent complex combinations of the variables that you have. And like the rest of code, they serve as additional documentation elements within your data set. So a lot of times if I have to make a specific adjustment to a variable because of a violation of an assumption or something, it's already documented in my code that this is exactly where and how it was transformed, because instead of having to explain what the formula means in an extra documented code, my function is able to explain it for me. This is just a list of some of the mathematical and statistical functions that you can find. For the most part, mathematical functions are especially useful when you're doing data transformations or because you're trying to address assumption violation, or if you just need to do just a slight tweak on a data element because it's not quite in the exact format that you need. Mathematical functions come in great use for that. Statistical functions, on the other hand, are very helpful when you're exploring the structure and suitability of data. So if you just need a quick mean or a quick standard deviation or something, those statistical functions really come in handy. And I put in the slides, there are links to those, as well as just kind of, if you look online, there's a lot of functions that just are not even mentioned in this little list because there's just so many that are available in SAS. All right, so this is my sample data set. That's just a snapshot. So we're going to go to the next one. There we go. This is the code to call it. This is a standard data set that's available within SAS. I chose it so that anyone that wanted to explore the functionalities of especially the mathematical statistical functions in there, this is a decent data set to work with. It's also one that I frequently use in my multi-collinearity presentations because there's a lot of different elements to work with in this. For the example, I chose to look at the base triglycerides that are in the data set because there's triglycerides that are measured at baseline and then triglycerides measured at the 3-month follow-up. And so I chose to look at just mean standard deviations and everything between triglycerides at those 2 time points. So I can show you how the functions work, both mathematical and statistical, and how easy it can be to just rely on the function, but that just relying on a function might actually give you errors. So to actually know how those functions are created is very, very meaningful, especially in this phase, because they are meant to assist us with the creation and exploration of our data. But if you can't just rely on like, oh, this is just a standard deviation, or this is just a mean. So I absolutely know what it is. Keep in mind that especially with statistical procedures, there are multiple different ways to calculate a very simple statistic. So we want to make sure that we're employing the right one. And we do have a limit to the amount of functions that we do have at our disposal. All right, so here is my code here. This kind of shows you different ways that we could calculate the just standard means and standard deviations. And I chose to write this monster of a little code because I wanted to show you just how complex writing a very simple statistic can be, writing it out, and how simple the use of mathematical and statistical functions can make that very complex code. So in the red, you're going to see that's just a standard deviation that's calculated for a population. I wanted to highlight this because the standard deviation function that's available in SAS and in the data step is actually used to calculate the sample standard deviation. So I wanted to show you that if you just relied on that stat function, you would probably end up with the wrong number. So I want to show you how to calculate that out by looking at the population, and then in the blue you can see that that is actually that function basically written out in its calculation for the sample standard deviation. So that's kind of the difference between those two sections. I also utilized a math function in there, the square root, because I wanted to show you how just utilizing that short little math function can help clean up that whole formula in and of itself. So if you concentrate on the yellow sections, at the beginning of each of the statements, I've got the square root that's stated in those second lines. And at the end of the line above it, you can see that that's actually the square root written out. And it took me a little bit, even as a statistician, to go, how do you represent a square root in a formula written out when I can't use the symbol? So how do I write it in a code? And that's how you write it. Now, if someone's just looking at your code, doing a cursory glance, they might miss that that's actually a square root. Whereas if you're utilizing the math function of square root, they automatically know, oh, I know exactly what you're doing, and yeah, that's exactly how it needs to be calculated. So that just utilizing that short little math function, clean that up a little bit and clean up your code and decrease your chance of error. And then at the bottom with the stats, you can see that utilizing those green stat functions right there, that cleaned it up even further by taking pretty much all the calculation out of it and just saying, I want to calculate the mean, the standard deviation with these two variables. So it made it really, really clean. All right, here is our output. So all of our calculations are in here. I kept the same colors. So in the red there, that's our calculations of the population standard deviation. In the kind of bluish purple, we've got our sample standard deviations. I highlighted where our math functions were used. So you can see even utilizing the math functions, that did not change our computations at all. It just cleaned up our code. Because, I mean, square root is kind of hard to mess that up unless you're actually trying to write it out. The function itself is, pretty straightforward and helped clean up the code a little bit, and we got the exact right answer that we needed. Between the population and standard deviation, or populations and sample standard deviations, you can see that there's quite a bit of a difference. It's about an 8-point difference between those two numbers. So that's something that we want to make sure that we're calculating the right standard deviation. If I needed population standard deviation and I ended up using the statistics function that's available within SAS, that stat function is designed for sample standard deviation. I would be presenting the exact wrong number. So it is very useful very important that you look at how the different stats functions and math functions are calculated, specifically the stats functions, to make sure that you're utilizing the right one in your code. If you need to write out a formula, you need to write out a formula. SAS hasn't taken into consideration every single statistical calculation that's available, so we want to make sure we're utilizing the right one. But when we did need to use the stats function, or when we did need to calculate sample standard deviation, the stats function came in really handy. Now, another little interesting thing with the stats versus math functions and just writing out the formula is that when I wrote out the formula, you can see that there is a certain subset of the population, or the sample, that does not have a triglycerides measurement at 3 months. So I had a missing variable. When it calculated the means, of course, it said, well, I can't calculate, with a missing variable, I don't know what to do, so I'm just going to say that I can't calculate this. So it completely skipped over any missingness that was in my data set, whereas the stats function said, okay, this is missing, but I'm going to calculate the mean for what I have. Since I only have one variable, the mean obviously, or the one value, that mean obviously is that one value. So that's also something to consider as well. Stats functions have basically built-in if-then-else statements, so built-in logic to take care of things like missing values. So make sure that when you're utilizing a function, especially stats and math, as straightforward as they are, make sure that the underlying coding that goes into those functions matches what you need to do with the data, because we don't want to invite an error or an assumption that ends up really messing with our results. So I did want to highlight that between the different calculations. Otherwise, stats functions and math functions, they make at least my life as a biostatistician so much easier. My code is so much cleaner and so much easier to explain, especially with things like when I have to take square root, because when you say I need to take the square root of a formula, you usually say square root of, not formula square root. So it's a lot easier to see that, and a lot nicer to see that mathematical representation at the beginning of my statement than at the end. And it makes explaining that procedure just a whole heck of a lot better, as well as making my code look a lot cleaner and easier to read for anyone looking at it. Okay, so in conclusion, we learned a lot about some different functions today. Functions themselves act as SAS subroutines. They work to take in arguments, perform operations, and then return a set of values based on the parameters set forth by that function. Functions result in much cleaner code. We gave several examples today on how previous ways of doing these calculations and variable constructions and everything can be really, really messy, difficult to explain, and really easy to mess up. Our functions allow us to keep our code relatively clean, easy to read, and decreases our chances of error. If you're looking to learn more about these functions and more, SAS provides a very large library of built-in functions that it has put inside SAS to make our lives easier as programmers. This is also documented in many SAS papers and books just across the SAS community and within the SAS world. So there's so much that you could utilize to learn more about these functions. Okay, some of the different functions that we covered today were CATT functions. These functions are quite diverse and are specifically designed to replace those concatenation operators, those double bars that, especially when you're a first-time programmer, you're going, what on earth am I looking at here? And then as well as those other functions that are used in conjunction with those concatenation operators, such as trim, trim end, left, and strip. So it just makes our code just a lot cleaner and straightforward right out the gate. Our PRXMATCH and PRXCHANGE functions were the next ones that were covered by Richanne. These utilize flexible pattern matching. They can be used interchangeably with some of the other SAS functions. And the learning curve, there is a learning curve due to unusual syntax and the use of meta characters, but that learning curve is well worth traversing, because this type of function really does make your life a lot easier when you have to do these complex combinations. And the mathematical and statistical functions are commonly and frequently used formulas built within SAS. There are different use paths that are designed to handle these functions that these functions are specifically designed to work in. And they're very useful in the data preparation phase. It is very important that no matter the function, whether it's mathematical, statistical, CATT functions, PRX functions, know the formulas that and the coding that kind of goes in behind them, because they are complex functions that are created, and we want to make sure that we're utilizing them appropriately. Mathematical and statistical functions especially, because those are really easy to take for granted. So we want to make sure that they are appropriately employed for our specific question. Great, thank you all for coming to our presentation. This is our contact information in order of presentation. So we've got Louise Haddon at Apt Associates, Richanne Watson with Data Rich Consulting, and then myself with Juxtapose, and I just use my Gmail. So feel free to contact us if you have any questions or want any more information as to why we love these functions. Thank you so much for coming.